Our guest of honor is Dr. Felix Munoz Garcia. He's a full professor of economics at Washington State University of Pullman. Also, Dr. Felix is a co-editor-in-chief of Economics and Governance, editor-in-chief of Lecture Notes in Economics and Policy book series, also associate editor of Economic Inquiry and Environmental and Development Economics. His research focuses on industrial organization with application on regulated market, including pollution industries, natural resources, management, and sustainability. So today he will present his research about economics of green innovation and emission reduction policy design for the energy transition. So please join me to welcome Dr. Felix Munoz, and the floor is yours, Doctor.
Thank you so much, Abdullah. Thank you again for the invitation to come to Saudi Arabia and and to the Saudi Economic Association for the opportunity to give this lecture and for organizing everything to make it possible. So let me start, before we get to more specific, let me start with an overview of the investment in green investments in the last few years in different regions of the world. These numbers are in billion US dollars. So in 2024, we can see basically the number of dollars in volume, but more importantly, perhaps, is the increase since 2020 and the projected increase in just 4 years from now. And the projected increase, this is probably more like subject to change or to projection error in 2040. They think that the most significant numbers are the ones, the change in 2024 relative to 2020 and the projected change just 4 years from now. Basically, what they signify and really highlight very kind of brutally and being very, very clear, right, is that even if by volume China keeps dominating the market and by innovations the US and EU are still really leaders and big players, by growth, the Gulf countries and Saudi Arabia are increasing way faster than anyone else, right? So that's quite impressive, right? That's basically what I mentioned in here, like the US and EU remain innovation leaders, but a slower historical growth, especially in the last 8 years or so. Most of the increase in relative to 2020 in the US was due to the Inflation Reduction Act that included many policies to reduce pollution, and the Green Deal or Horizon Europe plan, right, in the EU. So the Gulf region started from a lower base in the 90s, but grew extremely fast with Saudi Vision 2030, like a lot of R&D coming from Aramco, PIF, Agua, among others, and the UAE energy transition plans, right? Those are probably some of the biggest players in the region. So there are, of course, many green investments in different dimensions. Like, of course, one of the biggest is renewables. Here are some numbers for 2024 at least. This is worldwide and increasing. Hydrogen energy, again for 2024, of course, a way smaller number, but decreasing a little bit relative to 2023. Nuclear energy, 75 billion worldwide and increasing. It's basically, we are starting to see a little bit of an increase in nuclear energy investments. But basically, we are going to switch gears and say, what about abatement, right? So let me first of all define what we mean by abatement every time that we talk about abatement in statistics, economics, or finance, or other fields, right? Abatement basically in plain language refers to reducing emissions without replacing primary energy generation, right? So the typical examples are carbon capture and storage, basically end-of-pipe filters, projects of energy efficiency, grid and digital optimization technologies for energy usage, but basically not switching our energy sources to solar or to wind, for instance, but basically maintaining what we have, trying to make a better use of what we have, and trying to make sure that there is the least amount of emissions going into the atmosphere and the rivers and such. So this is an example of these carbon capture technologies. You can see here the contaminated gas goes into the filter. You can read like this liquid reservoir, packet bed, liquid distributor, but basically at the end of the day, the clean gas goes out and the scrubbing liquid goes out, right? So you have to dispose of the scrubbing liquid, of course, but overall, the net effect, it's positive for the environment. So abatement, to be frank, is often overlooked. When we think about energy transition, sometimes we think about green investment, like solar, wind, right? But it still accounts, it's not negligible in terms of as a share of total green investments. As we can see, it accounts for a large share in most economies. In 2024, for instance, it accounted for 20% of this green R&D in the US, 25% in the EU, 18% in China, or 18% in the Gulf region. These are all estimates because depending on which statistics source you use, the definition varies a little bit, but approximately it's around that number. The good thing is that in the last 2 decades, approximately, it has been extensively studied in economics, both from the perspective of industrial organization and game theory, but also from the perspective of environmental economics. In a way, it started with the seminal works of Poyago in 2007, but it got on more heavily with Lambertini and others in 2017 and later, right? So it's relatively recent. It's not something that started in the 80s or so. I mean, basically the technology was very kind of prehistoric back then, right? So it's a combination of two things. The technology got much better at filtering and doing a good job at an economical level, like inexpensive level. And at the same time, from a methodological standpoint, economists started to having the tools to analyze firms' strategic decisions with the tools of game theory and industrial organization in a more systematical way, to better understand how firms make those decisions, how regulators anticipate those decisions, and establish environmental policy or subsidies or any other form, right? So there have been many advances, and many of them are actually, I'm fortunate to have done many of them with a very nice group of co-authors, many of them former students, in the last 5-6 years. So the outline of the presentation, at least the plan, I mean, you can ask questions and such, but the plan is to first start with a very simple two-firm example of how firms tackle abatement, how they face that, what are their benefits and costs at a very intuitive level. What are the strategic effects that come into play when thinking about abatement between the firms and with the firms and the regulator? What are ERCs and ERGBs? Those basically, it's an acronym for Environmental Research Cartels and Environmental Research Joint Ventures, right? We'll talk about what do they mean and how they can be like a positive thing to consider from a regulatory standpoint. And actually they are quite frequent in many countries. Then we will take like a little bit of a detour, but we can stop at any point with these recent advances, where basically I will try to summarize like at least 2 or 3 of some of our recent papers. And then we can conclude with some policy implications. I mean, I will interject policy implications often too, but at the end we can kind of summarize with some take-home messages about what are the policy implications from many of the of this literature, right? Okay, so in terms of an example, so consider an industry, a polluting industry with 2 firms, right? Each firm decides how much to invest in abatement. This is typically referred in the literature as Z, right? But you can just think about basically you decide how much to invest, I decide how much to invest to reduce your emissions and to reduce my emissions independently. This investment reduces our emissions, right? Basically, you can mathematically write that down as the emissions being a proportion of my output. And after investing in abatement, they are less than that, right? Thanks to abatement. Of course, the investments are costly. You can think about some filters that are at least a few $1,000s. It can be like $1 million or more, depending on the industry and depending on the size, right? This is typically convex, meaning basically if you want to reduce, if you didn't have any filter whatsoever, the first basic filter that you could buy at the supermarket, just to make a little bit fun, right? It will be very cheap. But if you wanted a very good filter that reduced pretty much all your emissions, you will have to pay like $1 million, right? So basically it increases at an increasing rate, the cost to reduce 1 more ton of CO2 from your emissions, right? And then at the end, after those investments are done, firms decide what are their output or what are their prices, depending on how they compete, right? Okay. So of course, at this point, the typical question is why firms have incentives to invest in abatement. And plain English language is just to lower their tax burden, right? Basically, reducing your emissions provides 2 benefits. The first one is that if your tax, the amount of taxes you pay per unit of emissions remain constant, right? You would be generating fewer emissions, and as a consequence, your total tax bill would be lower, right? Basically, even if the amount you pay per ton of CO2 is the same, like 10 cents per ton, if you generate fewer tons of CO2, you pay less, right? But that's not the whole story. The story is richer than that, because by emitting less, the Environmental Protection Agency, like the EPA in the US, can anticipate that there will be less pollution, and anticipating less pollution, they can set a less stringent emission fee per unit of output, right? So basically those 10 cents we were referring to before in the example would be only 5 cents. So not only you would be reducing the volume, but you would also be reducing the price of each ton of CO2 that you have to pay, right? So it's basically providing you 2 benefits. And you will be comparing those 2 benefits against the cost of installing better and better filters, right? Eventually, you would reach an equilibrium where you would say, here is where I stop. I don't want to keep improving the filter because it's no longer worth it, right? Okay. But, and of course, that's, sorry, I almost forgot. It gives you one more incentive, one more benefit of investing in abatement, which is that by doing so, you reduce your total costs net of taxes, right? When you account for all your production costs, all your taxes costs, when you account for all of that, your costs go down. And that literally makes you more competitive against your rivals in the industry, other firms in the industry, which is something that you anticipate having an important effect tomorrow, right? When after your investment in abatement, you start competing with your rivals, right? So that's something important, and that's why firms don't want to be like the one like investing the least, because then they will have a competitive disadvantage tomorrow, right? Okay, so now what's the catch? The catch is that if by me investing more in abatement, I induce the EPA to set a less stringent fee, right? Because they anticipate less pollution in the atmosphere, then the natural conclusion is that that fee is applicable to everyone, not only to the investor, but to all the firms in the industry, the ones that also have to pay the fee, right? So by investing in abatement, I am basically generating what we call in economics a positive externality on my rivals in the form of a less stringent emission fee on everyone, right? So then, of course, what that generates is also what we call free riding incentives. Basically, it's like slacking, right? It's like you invest in abatement because by doing so, the tax applicable to everyone will be lower, right? I don't want to bear the burden of investing in abatement if someone else can do it for me, right? So basically, that's what we already mentioned. And of course, the implication of that is that as a group, we tend to invest too little in abatement. If we could coordinate our actions and decide to invest more, right? Like, okay, you invest $1,000 more, I invest $1,000 more, and so on and so forth, we would all be better off as a group, right? It's like has the same flavor as the prisoner's dilemma game, but in a context of investing in abatement, right? Okay, so that's basically the most simple environment we can think of. Now we start adding more realistic scenarios, right? One element that often happens in this type of technology is that it generates what we call spillover effects. Spillover effects, I mean, you can have a look at the math, but the basic idea is that if I invest more in abatement, now the emissions that the EPA generates on your factory are going to be lower, right? That's an explanation, right? Basically, the amount of detectable emissions on other firms is lower. Another way to interpret it is purely technological, is that if I invest in abatement, now you can use, you can kind of copy part of my technology, of that abatement technology, and abate, like reduce your emissions more, like less expensively, right? It's like at a lower cost, right? So the way this is introduced in the literature is by taking the emissions function that we saw before, where we compare before abatement emissions minus my abatement, and then minus beta and the abatement of other firm, right? This is new. So of course, if beta is equal to 0, spillovers are absent, and we are back into the traditional model we were talking about before. But if beta is a number between 0 and 1, a share of your investment benefits me in the form of less detectable emissions, right? However, we have to say that empirically spillovers are typically small. They are non-generally 0, right? So there are many industries where they are positive, but it's not that they are like 90%, of course, right? Yeah. Okay, so here's when we start talking a little bit about policy, right? So we identified two incentives to underinvest, right? Invest too little, what we called, informally speaking, too little as a group. One was the tax saving effect, like I invest in abatement and that reduces the stringency of the emission fee, and as a consequence, I pay less in taxes, right? And the other one is spillovers. Because I benefit from your investment in abatement through spillovers, I tend to slack and invest less, right? So we have basically too many free riding effects, right, coming from two sources. And the question is how to correct them, right? And there are two typical tools that the literature has used, and they have been extensively studied too in the last decade or so. One is the so-called environmental research cartels, right? Basically the idea of even if we are firms that compete like brutally and being really tough in prices or in products later on, today we are going to coordinate our investment in abatement, and that is going to be legal. That's why it's basically environmental research cartel. Our decisions of how much to invest in green R&D is something that we can coordinate and operate as if we were a cartel. Of course, the question of that is whether after coordinating our investments in abatement, we are also going to coordinate our prices, right? That will be really dangerous for consumers. But if you can have like a strong competition authority, right, like a FTC or a European Commission, or in Saudi Arabia, the market, like MEWA, right? I think it's called. You will have the ability to allow one while banning the other, right? Okay, so doing that, allowing for ERCs, addresses the tax savings externality, removing free riding incentives from that source, but it doesn't address the possibility of spillovers, right? The way to do that is through what's called environmental R&D joint ventures that basically address both forms of externality. That requires that not only you allow firms to coordinate their investments in abatements, right? Like whether you are investing 6 and I invest 5 or any other combination, right? But also that the results of our innovations, right? If you go through like an R&D lab and invent some new technology that helps reduce emissions by this much, you share all your new innovations with me and I share all my innovations with you. That mathematically generates a beta equal to 1, basically total spillovers between the two of us. Anything that you innovate, I benefit, and everything that I innovate, you benefit, right? And that would address the spillover effects too, the spillover free riding incentives, right? Okay, the policy implications of that before we move to other sections is that in the Gulf, for instance, they could explicitly legalize ERCs. Like you can think of Aramco, just to give you a hypothetical example, right? Aramco, SABIC, and petrochemicals coordinating their R&D decisions. That is particularly useful since green R&D is lower, relatively speaking, right? And the Vision 2030 programs could incorporate that ERC participation as an approved collaboration mechanism in order to access like subsidies or other support, government support, right? And a similar framework for ERGBs, right? Focusing on carbon capture or in carbon intense industries, like that. Those are quite strong in the region, right? Where spillovers matter, right? Because there is always going to be some spillover effects going on, even if they are small, right? Okay, so now let's move on to some of the most recent advances in this literature. Some of them are published, some of them are not even published yet. So, I mean, we're kind of, you'll be some of the first ones to know about them, right? So basically, in terms of the literature, the foundations, as I mentioned early on, were starting to be clear in 2017. But there were still many questions open, right? And many questions with real policy implications, right? So one is, what if firms invest sequentially rather than simultaneously in abatement, right? Maybe there is an industry leader, or they are making huge investments in abatement, which are typically the case in some cases. And those are perfectly observable. I mean, if you are investing in like a 1 million filter, your rivals can see it just by driving close to you, and they know that you are about to finish installing that filter. Or what if firms invest in both cost-reducing R&D and green R&D, right? Meaning you are investing in two forms of R&D at the same time, rather than like investing in one today and years later in the other, right? Again, we'll see what happens. Or what if firms use only a share of their installed abatement capacity? Again, we are going to see some examples where actually that occurs. or at least for the US, there are many firms that after installing a very expensive filter, they realize their usage cost is so high that they better use only parts of it, or they intermittently use it in order to reduce usage costs. Or what if firms use their investment in abatement to influence merger approvals, right? Again, that's a very underexplored literature where you combine environmental regulation and merger approval decisions to see how the overlap of two agencies on the same industry changes the results, and importantly, changes the policy, like how the EPA or the merger evaluation should change, right? Okay, so let's go through the first one. Again, I'm trying to minimize equations. So here is the basic idea is that abatement decisions are typically simultaneous only in small investments. You can think of end-of-pipe scraps, right? That are often less than $200,000 or definitely less than $500,000 for many industries, right? But if you think about bigger investments, they are more typically sequential, like cleaner machinery, filters, cleanup after an oil spill. All of those abatement projects are way more, way larger, allowing your competitors to see your abatement plans before they react, right? Because the projects take often years to complete, right? Examples of large investment projects abound, and they may take years, as we already said, allowing firms to observe their rivals' abatement, right? So that's basically why sticking to a simultaneous abatement decision is not realistic, right? And we have to adjust the model to see how regulation would change, right? So in that paper, it's actually a very short paper we did with one of our former students just a few years ago. What we show is that there is what we call a first mover advantage. Basically, the first firm to invest in abatement can benefit from being the first, right? From investing the first. And this stems from a less stringent fee in the next stage. In order to understand that, basically the idea is that if I'm the leader in the industry with investing in abatement before any other firm, when my costs of investment are low, right, then the benefit from investing in abatement, right, which is the tax savings effect, right, like producing a less stringent fee, then I invest more than the follower, right? But otherwise, I will be a free rider. This is basically a very similar behavior as what you see in a contribution to a charity or in a public project, right? If I know I can free ride on the second mover or the third mover, I will slack today, just like donating very little to the project in terms of effort or money, anticipating that the second mover will be forced to donate more effort, right, in order to have the project completed, right? So the way we illustrate that in the paper after finding the results is that if the cost of investing in abatement is relatively high and pollution is relatively severe, right? Sorry, is relatively not severe, D is low, the leader is a free rider, right? But otherwise, the leader doesn't free ride and actually donates more, or in this case, invests more than he would under a simultaneous setting, right? Okay. Now, the other possibility, the other extension in that recent advances in the literature is the simultaneity in different forms of R&D, right? So what do we have in mind? So if you look at the statistics about firms' investment in cost-reducing R&D, right, in order to make their products less costly to produce, you can find huge numbers like this 625 billion in the US or 310 billion in the EU. I think this was from 2024 or 2023, right? Then if you separately look at environmental R&D, it has also increased as we started with today with 100 billion in in 2024 for at least exclusively R&D, not green investments in general, but exclusively R&D projects, right? That also applies to Saudi Arabia with petrochemicals, refining, and desalination, engaging in large cost-reducing investments, right? Okay, but what's the point? So the issue here is that each investment has separately received attention, right? The cost-reducing R&D from the traditional industrial organization literature and even in management literature and so on, right? And the environmental R&D from engineering, but also, of course, from environmental economics, energy economics, and so on. But the issue that we are addressing in the paper is that both are happening at the same time and decided by the same firm, right? So this has been largely overlooked. And most companies actually reveal or recognize in many surveys that they every year they decide how many millions to allocate to both projects, to the cost-reducing R&D and to the environmental R&D. Especially big firms do that every time, right? So basically the question that we pose at a very fundamental level is under which conditions firms invest only in one of them, only in cost-reducing or only in green R&D, and in which cases they both invest in R&D. So what we want to analyze, what we want to analyze is those decisions, but of course the most critical question is how that impacts optimal regulatory design, right? If you are the EPA and you know that the firms are simultaneously choosing both rather than only one, right? How should you basically update your policy, right? And what we show is that it can differ a lot, right? But only in some circumstances. And that's exactly the main interest, right? In which are those circumstances? Of course, at this point, many of you may be wondering, hey, why not just analyze each of them separately? And that's it. That should be enough. And we could do that, but that would only be true or would only be correct if what we call the marginal benefits and costs were additively separable. I know that sounds very technical. So in plain English, what does that mean? But what it means is that if I'm a firm and I were to decide investing $1 more million in cost-reducing R&D, my benefits and costs of investing in green R&D should be unaffected, and vice versa. Investing more in green R&D should not impact my incentives, my benefits and costs of investing in cost-reducing R&D. If that was the case, then analyzing the two of them separately would be the way to go, right? And all the separate literatures would be correct until like 2 or 3 years ago. But then we ask, but are they separable, right? Can we analyze them separately? And we argue that no. The first, probably the most important argument is that benefits of investing in either are not separable. If firm one, if you have like a two-firm industry or n-firm industry, doesn't matter. If one firm invests more in cost-reducing R&D, they will have lower costs, lower production costs, and then they will be able to produce more units. And as a consequence, they will emit more emissions, right? More pollution. That will trigger a more stringent emission fee because we know that the EPA adjusts the stringency of the emission fee depending on aggregate pollution, total pollution. But if the emission fee now is more stringent, as a firm, you have more incentives to increase your investment in green R&D in order to abate more and reduce your tax bill, right? So basically, we just saw that investing in one form of R&D increases your incentives to invest in the other, right? So they are not separable. The costs may not be separable either, right? There are many examples of from the fast fashion industry, like H&M, the Gap, and other typical brands, right? We're using these waterless dyeing technologies in the textile industry, where innovations originally developed to reduce emissions, like this waterless dyeing technology, can also be beneficial to reduce your production costs, right? So that is what we call in economics, economies of scope. by investing in two things, right, you reduce your overall costs, right? It's like investing in one thing reduces your costs in the other, right? And for generality, in our paper, we also allow for what we call diseconomies of scope, which are very typical, actually, have been reported in the EU, where investing more in green R&D increases my production costs, right? So we allow for both directions. Here, basically, don't get crazy with the jargon and the notation, but basically what this figure is trying to report is that every time that these ratios are below 1, considering that the firms invest in one form of R&D rather than both simultaneously, would be underestimating how much they invest, right? Meaning firms are investing more than what you expect from the traditional models, right? So if you are the EPA, like an EPA official, and you think, oh, I'm going to regulate this pollution industry or polluting industry by looking at the traditional literature, you will be anticipating they are investing too little in abatement and too little in cost-reducing R&D, and that will have an important effect on your taxation, on the emissions fees, right? We show in the paper too that you end up under-taxing, like setting a 2 lakhs of a fee under most circumstances. So here we just summarize the presence of 3 externalities, but I think that it's not necessary at this point. I think everything was clear. You can refer to it later. Or to my papers, right? So this is the under-taxation problem that we mentioned before. It arises even if you don't have economies of scope, right? Meaning that it can be actually very problematic because you will be setting a very low fee. And remember that a very low fee means the firms are polluting more than what it be optimal, right? Generating a welfare loss for the society. So in terms of practitioners, right, if like an EPA official showed up now and said, don't get crazy with the model or the math, please tell me when is the under-taxation the largest? In other words, in which industries I have to be more aware of these simultaneous 2 forms of investments happening, right? And in which industries it's okay that I overlook it, right? And the answer is that you have to be really critical when pollution is severe, when the cost of investing in R&D and in green R&D is low, and when the industry is relatively concentrated, right? It's less competitive, like 3 firms, 4 firms, but not 100, right? In those cases is when the under-taxation problem is the largest, right? Otherwise, ignoring the multiplicity of investments and just taking a very tractable model from the traditional literature is going to yield an emission fee that will be very close to actually the one we find, allowing for multiple investments. In other words, the regulatory error would be very small, and it's probably it's okay, right? And it's more practical. Okay, so moving on to usage decisions, right? So the main motivation of this paper is that in many industries, usage costs for abatement are large. The literature has largely overlooked that as if usage costs were 0. You install a filter, like $500,000 or whatever, and then you don't have to incur any usage costs to maintain it through the 10, 20 years life cycle of it, right? So, but as you can read here, scrubbers for acid gas control face annual operating costs exceeding $500,000 per year, right? So it's definitely non-negligible. And the EPA reports unused end-of-pipe controls, such as wet scrubbers and backhouses in coal-fired power plants, cement industry, chemical industries, with these unused end-of-pipe controls, right? So as I mentioned before, the literature has assumed full utilization, as if usage costs were negligible, but clearly $500,000 is not negligible, right? And even if they were lower than $500,000, the EPA reports shows that firms are strategically deciding to install abatement, but then you don't use it fully. So if they are doing that, it's because it must be profitable, right? So basically, strategically having capacities sitting idle, right? So that's basically what we want to understand. So, but why does it matter, right? We always try to ask this question to ourselves when starting new research, right? So, of course, several firms report partial use of install abatement. We already talked about that. And in terms of policy, regulators that incorrectly assume full use could be setting 2 lakhs of an emission fee. And that's actually one thing we show in the paper, leading to a socially excessive pollution, right? Basically another, like once again, an undertaxation problem, right? So the main results with, again, no math in here, is that when installation costs are expensive, we show that full capacity arises, but endogenously, it's what we call in equilibrium, right? Basically, if you allow firms to decide whether or not to use their full capacity or to use like a specific share of it, like 10%, 20%, or any other percentage, they will decide to use 100% when installation costs are expensive, right? So that's actually good news in a way, because we are basically giving like a compliment to the literature, saying, look, the literature was right by assuming full usage, but only when installation costs are expensive. Otherwise, when installation costs are less expensive, what we find is that partial usage is the equilibrium of that situation, where firms only use a share of their installed capacity, right? So the way to understand that result is that firms actually think about it or analyze it in like mathematically as what you do in finance when you invest in a portfolio of investments, right? In this case, your portfolio is how many dollars to invest in capacity and what percentage of that capacity to use, taking into account the costs of each, right? Which can be non-negligible, right? And what's the goal of the firm? To combine the two, the portfolio, in order to maintain what we can interpret as net abatement constant across the scenarios. Net abatement understood as the share of my installed capacity times my total capacity, right? Gives me essentially my usable capacity, right? Or net capacity in terms of abatement. And that it remains constant throughout all the scenarios, regardless of how the emission fee is, how many firms are in the industry, etc. Right? So that's important because the installation of this abatement capacity is very often subsidized. I bet that there are some subsidies in Saudi Arabia, and there are many in like the EU and the US, right? So what's the problem, right? So if you provide subsidies for the installation of new capacity, it's true that they can increase the abatement installation, right? Firms benefit from the subsidies. They see that their installation costs go down, right? And they install more. But as we show in the paper, like a very low installation cost, either because it's naturally low or because it's subsidized, can induce firms to reduce their usage, right? They install a lot, but then they realize that the installation is so big that they cannot profitably use all of it every period, right? So they reduce usage, leading to no significant changes in total emissions. Right? You can basically have in the media, oh, these firms are investing millions of dollars in end-of-pipe technology, but then basically tomorrow they only used 30% or 40% of that installed capacity, implying that total emissions are not so much affected, right? So one way to try to anticipate that or adjust for that in terms of policy is, for instance, to condition subsidies to usage levels, right? The EPA monitors usage levels, and I bet many other countries can do that too, right? So not only based on installed capacity, but on usage levels, even if it's like random monitoring every few times a year, right? That can be done nowadays actually with digital monitoring without having monitors going through factories or installations, right? So the carbon capture in Vision 2030 could be tied to capture CO2, not just to install capacity, right? With that enough, would take into account the results in the paper, right? And the last one is these abatement thresholds, how merger prospects affect green investments, right? And the motivation behind this paper is that in several high-profile mergers, there you go. Firms increase their green investment years before submitting the merger request. So basically, it's the time sequence of you are a firm that you are about to submit a merger request to the FTC, right, to the Federal Trade Commission, or the European Commission, and similarly in the Competitions and Market Authority in the UK and such, right? And like without any change in environmental policy, you are still subject to the same regulations. You suddenly invest quite a bit more, right, in green R&D. And literally within a couple of months of that, you submit a merger request for a merger between you and your rival in order to be approved by the FTC. That's actually what happened in many of these cases that you can see in the screen. Like Siemens invested $1.2 billion in offshore wind R&D during 2015-2016, prior to its merger with Gamesa in April 2017. That's when the merger was approved, but the merger was submitted way before that, right? So basically, it's within literally months of the merger submission that the increase in investment happened, right? Or Danish Ørsted invested 1.5 billion in the US on wind and solar before merging with Lincoln Clean Energy. Or Schneider Electric invested 800 million in a smart grid and energy efficiency before merging with L&T in 2018, right? So they are always very close, right? And we have many other examples from Japan and other regions in the paper. So if you go back to the press releases back then, so the typical justification was that investment in green technology was part of the firm's sustainability goals. And that can be perfectly fine, right? Maybe they want that to increase consumer demand and improve their CSR, right? Corporate social responsibility. But what we ask ourselves is whether there can be another reason. Not a substitutable reason, but a complementary reason, like one more reason for that investment to happen. And what we show is that, yes, basically the answer to that question is yes. And the reason is that by investing more in green technology today, I can influence the antitrust authority's evaluation of the merger request, in short, improving the chances of the merger being approved, right? So in order to do that, we consider a very similar timing than the models and the example I gave you early on today, right? In the first stage, firms invest in abatement, then the EPA responds with a per unit emission fee, and now the third and fourth stage are new. Then firms decide whether to submit a merger request to the antitrust authority, and the antitrust authority approves or blocks the merger. right? And then firms compete, right? So basically, the stages in italics are new relative to all the models we have been seeing today, right? So with that, again, we have all the technical details in the paper, but the idea is that we show the presence of what we call abatement thresholds, right? It's basically a minimum aggregate level of abatement that as an industry, right, we have to reach for the antitrust authority to approve the merger. If we fall below that, the antitrust authority will not be approving the merger, otherwise it does. Now, you may be wondering why the antitrust authority approves the merger doing that. Well, it's the typical reasoning of if you are the antitrust authority, you know that the merger will be bad for consumers, right? That's what you can label as a negative effect. But it also has a positive effect, which is that because there is a little bit of less production, there are also fewer emissions than before the merger. That's the positive effect, right? Now, if the firms invest enough in abatement, the positive effect is going to dominate, right? Meaning overall welfare the overall effect of the merger is going to be positive for society, and then approving the merger is actually good, right? But that happens, that's a big catch with that. That happens only when the antitrust authority assigns a moderate weight to pollution. So if you are the antitrust authority in many jurisdictions, you consider like the effect on consumers, the effect on profits, and perhaps you consider the effect in the environment on pollution, right? Now, that is the last part, the last leg, right, is what really drives the results. If you ignore pollution altogether, like the FTC in the US, not assigning any weight to pollution, like ignoring the pollution effects of the merger, then firms' behavior is going to be unaffected, right? They assume that the merger will be blocked, regardless of what they do in terms of green investment, so they are not going to invest. Same thing happens if you have a very pro-environment EPA, like this has been the case in some merger decisions in the EU, where the European Commission explicitly said that some of the reasons they have for approving the merger was actually the reduction in emissions that they anticipated, right? In that scenario, the merger is going to be approved regardless of whether we invest a lot or not, right? We are going to have incentives to invest. That doesn't mean we don't invest. We are going to invest a little bit in both scenarios, right? But the presence of a potential merger approval is not going to affect our investment decision today. But if the antitrust authority assigns a moderate weight on pollution, as we write in here, in that scenario, the prospect of the merger is going to induce us to invest more than what we would have otherwise, right? In order to basically trigger the merger, right? We summarize the results or depict the results with this figure, but it's probably unnecessary, right? So the results at a fundamental level, they draw a big parallel from the public good games, or what we call in economics public goods, right? With threshold effects, right? In order to understand that, just think of like imagine that we are contributing to a charity or to an NGO, and suddenly Warren Buffett or like a millionaire shows up and says, look, if you reach $10,000 in donations, I will match it, right? I will match those $10,000 with another $10,000, okay? So that has been proven to reduce free riding incentives in those donations. Basically, we tend to donate a little bit more in order to reach that threshold level of $10,000 and benefit from the matching grant of Warren Buffett, right, or the millionaire. Well, in the current context, we are facing a very similar story. On one hand, every time that I invest more in abatement, if I'm a company in an industry, I know that by doing so, I reduce the stringency of the emission fee. The EPA will adjust the emission fee downwards. And that is beneficial for all the industries for all the firms in the industry. Just like donating more to an NGO benefits everyone, right? But on top of that, now we know that if I am capable of driving all the all the investment in abatement up to the minimum threshold that we need to reach as a group, as an industry, we will have the merger approved. This is exactly the same as donating a bit more to the charity in order to reach the matching grant, right? So the latter effect is new in the environmental econ literature. There are no previous results on that. As we mentioned before, it ameliorates the free riding incentives in abatement, and it's actually quite robust to extensions. I mean, in the paper we allow for increasing costs of production, spillover effects, different costs. I mean, and it's is robust to all of those changes, right? And it has implications for both environmental policy and merger policy, of course. In terms of environmental policy, basically the main result is that abatement is higher, right? When firms anticipate a potential merger tomorrow than when they don't. So that implies that the EPA should set a less stringent emission fee. Otherwise, you will be overtaxing, right? Now it's basically an overtaxation problem if you don't adjust for that. So in other words, or like more like plain, right? If the EPA ignore the presence of that future merger request, right, it will be setting a socially excessive fee, right? Too high of a fee, right? And too high of a fee means firms are going to shrink their production, and that hurts everyone, like the consumers too, right? And what about merger policy? Well, with mergers, we show that when the AA places a moderate weight on pollution, as we said before, right, abatement increases, right? And this is purely due to the prospect of a merger request, right? It's not due to changes in cost, changes in EPA, nothing, right? So now, if the antitrust authority assigns a very high weight on pollution, like still lower than the EPA, but like a lot of consideration to that, investment behavior is unaffected. Why do we say that? Well, because there have been a lot of debate from legal scholars to public policy schools to econ departments, like a little bit of like all of these fields have recently touched on this issue of essentially what should be the criteria for antitrust authorities when they evaluate merger requests between two or more firms, right? You can think of many, right? The FTC basically considers aggregate output. If they anticipate aggregate output to increase, they approve the merger. Otherwise, they block it. But other regions, especially the EU, Australia, and Japan, have considered a more like welfare encompassing like analysis of or merger evaluation or merger guideline, as the typical jargon, merger guideline, when new mergers are like come to their desk, right? And sometimes the weight on pollution has been potentially excessive, right? Excessive in the sense of what we just showed, right? If you assign a lot of weight to pollution, even if you are more conservative than the EPA, you can be not having any effect on firms' incentives to invest in abatement, right? They invest, but not more, in order to increase their chances of the merger being approved, right? And that's kind of a lost opportunity, right? So that's why basically, or kind of in just one sentence, or policy recommendation, or like public policy recommendation, is that partial, but not full, regulatory alignment between the two agencies, between the EPA and the FTC, right? Or basically between environmental regulators and merger assessments, right? Or the like agencies of competition agencies, is the most effective way of increasing abatement, right? Not ignoring it, not full alignment, but partial alignment, right? So I understand that the General Authority for Competition in the Kingdom of Saudi Arabia recently has new merger guidelines, right? Well, what our paper is like saying, well, when you revisit those guidelines into the future, You can adopt explicit welfare criteria when reviewing mergers, so firms can exactly know what to anticipate before submitting a merger request. But importantly, not assign the same weight as the energy ministry, right? Like the MIWA, right? That will be basically what we said above, right? Not full alignment, not ignoring pollution, but partial alignment, right? So, and that would increase firms' incentives to invest in abatement, right? Okay, so at that point, we ask ourselves, are we done? I mean, there are all of these papers, all of these results. It looks like there is nothing left to do. Well, there are many, many lines of research still open for young and senior scholars, right? So there are many opportunities for research. One, of course, is to allow for what we call firm heterogeneity, right? You can think that firms have access to different technologies, and that makes one firm more experience lower costs of investing in abatement than others, right? Maybe they have better access to capital markets or better labs, right? So that is going to generate more asymmetries between the two of them, like how much they invest in abatement. Another is the presence of spillovers, but input spillovers or output spillovers, right? Input spillovers would be in using technology from other firms, right? Like I can copy part of your technology, and output spillovers is free riding the outcome or the innovation of your rivals, right? Or disruptive investments. This is actually something we started also a few years ago.
शाम को मिलके भी डिस्कस कर सकते हैं और डिनर कर सकते हो। आकांक्षा बोल रही मुझे ऐसे क्यों लग रहा है कि कल भी हमको कहीं कुछ याद नहीं आ रहा है और फिर कल हम लोग नॉनवेज तो नहीं खा सकते ना।
Please, Dr. Pooja, please mute the microphone.
Okay. No, sorry, I just noticed I went a little bit above an hour, but we are almost done. This is my last slide, I promise. So by disruptive investments, we mean investments that if I invest in abatement, I can increase my production costs, right? Because you can think that there are, actually we have examples in that paper of situations where a firm invests in R&D to make their production cleaner, and you have to use many of your engineers and tech people that was typically dedicated to other tasks to be dedicated to the green R&D, at least the installation phase and adjustments for a few weeks before they can return to their typical operations, right? So of course that generates some disruptions in your production line and in your output ability, right? The capacity to produce more that has to be accounted for. Another paper we recently published in Resource and Energy Economics is this allowing for investments in climate adaptation. So typically in many countries now you are seeing large investments in what's called climate adaptation, like elevating the height of roads, right? Or requiring the entry of some houses to be in what it was the second floor, right? It's literally that heavy, right? Especially in coastal areas, in the coast of all the North and South Carolina, Florida and such, right? But those investments, of course, are generating less incentives to invest in green R&D for some companies, right? And they also affect environmental policy, right? So that's something we explore in that paper too. And other extensions are like, of course, the possibility of mixed oligopolies, where you have public and private firms competing in the same market with different degrees of privatization and nationalization, and patenting or licensing green innovations across firms, right? Okay, and that's all. Thank you.
Thank you very much, Dr. Felix, for your presentation. Thank you for your insightful presentation, and we appreciate how you connected the theoretical model to the policy implication in Saudi Arabia, which is really insightful, I mean. And now we will open the floor for questions, and I think we have the first question from Prof. Muhammad Aguili. So please, Dr. Muhammad, feel free to ask.
Okay, thanks, Prof. Felix. It's an interesting lecture. There is a question just jumping to my mind regarding to your motivation slides. That how should policy balance carbon pricing and green R&D for optimal emission reduction?
Well, basically the immediate answer is that carbon pricing should be decreasing in green R&D, right?
Yeah.
So basically, if you have a good monitoring system to measure like the tons of CO2 or other pollutants that the firm is generating, the firm should the stringency of that basically the equivalent of the emission fee is the carbon pricing, right? The price of each ton of carbon should be lower because you are trying to take into account the aggregate emissions in the whole society, and when you take that information into account, if that amount is lower because of more green R&D, you can adjust the price of carbon downwards, right?
Okay.
Yeah.
Thanks.
Yeah. Thank you.
Any other question? Then if not, I think we can conclude the presentation. Thank you again, Dr. Felix. Thanks to the all audience for attending the seminar. Thank you, Doctor.
Okay, great. Thank you. Thank you, everyone. Really appreciate it. My pleasure.
Thanks.
Thank you.
Thank you, Professor Felix, for the lecture.
Thank you.
Question, Professor Felix. Yeah, I mean, we see the theories, we see everything. Thank you. Can we see it in real life? Is there an example of this application in real life, or like in the USA, or we can see it in Saudi Arabia?
So examples of what in particular?
And the application that you show us in the paper, like if yeah.
So for which of the papers?
No, yeah. So the paper that you share with us, the application when we have like two firms decided to investment in environmental R&D or
yeah. So that was like a general idea applicable to all the papers, right? So in some of them you have then the possibility of going sequential. In others you have the possibility of two forms of investment. Basically, for instance, in the case of firms investing in both green R&D and cost-reducing R&D, I think that if you pick any big firm in Saudi Arabia, you are going to, after doing some research, you are going to find that they're investing in both. Even if it's a little, I suspect that no large firm nowadays can afford to say, I'm not investing anything in cost-reducing R&D, because they always have some engineers and labs trying to make their production more efficient through time, right, for the next year, right? And at the same time, they are also thinking about how can we make our production a little bit cleaner, even if they don't care about the environment, just because they want to pay less taxes, right? So that's my idea. Even like medium-sized firms in the US and many other countries invest in both. So that's why I think that if you start like doing some analysis from their yearbooks and such, you are going to find that they invest in both. Yeah.
Thank you.
Yep. Good.
I was okay. Anyway, you are leaving. Sorry, I wrote my question, but never mind.
Oh, I believe that for oil and gas produced countries like Saudi Arabia, we should invest more in R&D to reduce.
Exactly, in cost effective energy saving and less pollution than in the green, because we have comparative advantage here. We should not lose this comparative advantage of our abundant resources and develop a green and forget about these resources, which is the backbone of our economy.
Uh-huh.
Yeah, that's as an economist, this is my
So,
by
let me see if I understand. So
yes.
we should invest more in R&D to reduce the cost
and the CO2
yes,
rather than in the green, pure green, less in the green. I don't say no, but
yeah.
less, but more in emission
Oh.
control.
Well, that's exactly
So that we can capture our comparative advantage much more and be more competitive.
yeah, well, that in a way, that's exactly what our paper was saying. Rather than
I hope so.
focusing on only one, right?
Exactly.
You invest in both, right?
Exactly.
Yeah,
I
yeah,
mean,
yeah, yeah, yeah.
This should be really the best recommendation for oil-producing countries is don't give up on your cheap resources, because these are going to be the weapon for your economic competitiveness worldwide and build your economy. But use them inside rather than only for export.
Okay. Yeah. Yeah. Good, good.
Thank you.
Thank you. Okay. So there are no more questions. I'll close.
There are no more questions, Dr. Moritz. I think now we can finish the presentation right now.
Okay.
Thank you. Thank you very
Thank
much.
you, Dr.
Thanks
Phillips.
again.
Thank you.
Thank you.
Bye-bye.
Thank